Hey everybody, today we're going to multiply and divide rational expressions. So what I'd like you to do is make sure you have a piece of paper and a pencil handy. Time to take some notes. All right, get a piece of paper, get a pencil, jot down these notes with me. All right, are we ready? Here we go. All right, let's begin by remembering how to multiply fractions and divide fractions. So over on the left, I have two fractions, 2 over 5 times 20 over 3, or 2/5 times 20/3. The rule for multiplying fractions is top times top, bottom times bottom. So I can go straight to the top times top is 40, bottom is 15, reduce 40/15ths by a factor of 5, and I'm left with 8/3. Or I could do some cross canceling. I know that 20 is divisible by 5, so 20 over 5 cancels down to 4 over 1, which gives me 8/3. So I don't care what you do, multiply top times top, bottom times bottom, and then cancel, or do some canceling and then multiply. Again, top times top, bottom times bottom. All right, then over here on the right, let's divide the fraction. So 2/5 divided by 20/3. The algorithm or the steps for dividing fractions is to skip, flip, multiply. So you're going to skip the 2/5, you're going to flip 20/3 to become 3/20ths, and then you're going to multiply those two fractions together. So just like I did on the left, 2 times 3 is 6, 5 times 20 is 100. 6/100ths reduces by 2 down to 3 over 50. Or notice down below, I cross-canceled first. 2 and 20 reduce down to 1 and 10, so I'm left with 3 over 50. Either way, you're going to get the same answer. All right, so you know me, I love to make it harder. Here we go with example 1. So I could start by multiplying across the top. That gives me 12v squared. And then multiply across the bottom, 15v to the fourth. Now 12 over 15, both 12 and 15 have a factor of 3, so I can reduce that down to 4/5. And then I can cancel 2 v's. That leaves me with 4 over 5v squared. The 3's cancel. So 4 over 5v squared is what I'm left with there. Now here's another example where I'm multiplying. So I'm still going to multiply the top times the top and the bottom times the bottom. But this time I have binomials and trinomials, all sorts of good stuff. Remember from yesterday, you cannot cancel until you have factored. Maybe you're going to factor out a greatest common factor like I did right here. 6m squared plus 6m. I can factor out one of the 6m's. I'm left with m plus 1. Think about reversing the distributive property. Would you be back to where you started? Yes. All right, then in the denominator on the left fraction or the left rational expression, I have a trinomial. So I do the big X and I think, what are two numbers that would multiply to 2 but add up to 3? 2 and 1. Both of them would have to be positive in order to add up to positive 3 and multiply to positive 2. All right, now that I've factored everything that can be factored, it's time to cancel. Remember, you can only cancel monomial expressions or binomials that are wrapped in parentheses. M plus 1 can be canceled because those are wrapped in parentheses. I can also cancel out the 6's. Now for a final answer, just read across the top. I'm left with 1m or just m, and on the bottom I'm left with m plus 2. Keep it wrapped in that safe set of parentheses. You can't go wrong. All right, now, again, m plus 2 is wrapped in a set of parentheses, so if anything's going to cancel with that m plus 2, it also needs to be wrapped in a set of parentheses and have a 2 being added. So, moral of the story, don't cancel those m's. No! All right, example 3, now we're dividing. So top times top, bottom times bottom applies to multiplication, but the algorithm for division is skip, flip, multiply. So notice what I did. I skipped the first fraction, I flipped the second fraction, and I changed the operation to multiplication. Then, just like we did in example 2 and in example 1, factor out a greatest common factor, factor out a greatest common factor. I'm going to give you a minute to think about that. Does that make sense? Factor out a greatest common factor from 20n squared and 20n, 10n squared and or 10n cubed and 10n squared. All right, I factored everything and now I can cancel. Cancel things that are wrapped in a set of parentheses if they're the same, n plus 1. I can cancel the 7's, 7 and 7. I can reduce 20 and 10 down to 2 and 1. And then I can cancel out one of these ends. And here is gone, and then I'm left with a single n down here. Now just read across the top. All that I have left on the top is the 2. 2 is the only thing that didn't cancel. And what's left on the bottom? The n. The n is the only thing that didn't cancel. All right, if you need, when you're doing your homework, if you need to come back to this example, look in your notes or rewatch the video. I do have one more example. This is as bad as it's going to get, in my opinion. We have got a lot going on. We have a constant 5. We have a binomial. We have a term with a 3k squared, so that's not constant because it's got a variable with it. It has a variable with it. And then we even have a trinomial to start us out. All right, so this is what we're given. We need to skip, flip, multiply, skip the first fraction, flip the second fraction, change your operator to multiply, and then factor. You lucky dogs, you get to do anything, every single sort of factoring you know. Factor the trinomial, what multiplies to 3 and adds up to 4, 3 and 1. Let's see, down here is the greatest common factor, kind of factoring. What can you pull out? A 5. You're left with k plus 3. Then cancel your brains out. K plus 3's cancel, 5's cancel, and then just read across the top what's left. K plus 1, what's left? 3k squared on the bottom. All right, I wish I would have kept my parentheses around the k plus 1. Now, I'm not going to mark it wrong if you don't have parentheses, but you're going to be less tempted to cancel one of those k's if you keep that binomial wrapped in a set of parentheses. You can only cancel this if it's k plus 1. The plus means that k is off limits for multiplying, or canceling, I mean. Okay, that's all I have to say about that. Remember, if you need some help, rewatch the video or go back and look at my work. Just get to this example and then pause the video and read through my steps. All right, so kind of same deal as we did yesterday. Go back to the Google Classroom. I have a PDF with some examples or homework problems, and then I want you to do them and then answer on the Google Doc. It's just easier for me to grade. I hope everybody's doing great. I sure miss you guys. Yesterday would have been the day you took the SAT. Well, maybe next fall. All right. Have a great day, everybody. Bye.